Now we are moving on to our next presentation. The presentation comes from Chris Pretorius from Siemens. And Chris is a sales director in the smart infrastructure business of Siemens AG, and he will show us the take of Siemens on green operations. Welcome, Chris.
Thank you, Sarah. Chris Pretorius here, and hello everybody. I'd like to speak to you today about a smart infrastructure. Now, this is something that typically people think is concrete and stuff like that, which it is not. In this case, we're actually talking about the electrical infrastructure and the related infrastructure. So if you look at this diagram, you will see we've put it in a bit of a simplified way. Everything that is in the green area down below is what we call the power supply, fire, security, safety, all of this stuff. So what it means is to keep a terminal running or a port running, you have to have a solid and efficient infrastructure, because without electricity, nothing's going to work. Without access control, nobody's going to be able to get in out of the gate. So this is where we focus. This is where we provide the solutions for ports and terminals around the world. And you can see there's numerous other special things in there, things like ship-to-shore supply, shore supply, special scanning solutions, all of this sort of stuff. So a lot of different aspects, very complex and everything, but it's not a real issue because we've done this before many times. What I'd like to do now is carry on and just cover a few points of this whole broad aspect, which means the first thing to consider is how to work with all of these different aspects and how do they interact. Because if you want to make an efficient operation, you have to consider what we call sector coupling. How does the transport transition, how does the thermal transition, how does the electrical transition, how do they all work together? And these are some of the points to consider, but it's a three-dimensional picture. Unfortunately, we cannot show it here, but you can imagine things like charging infrastructure, it relates to electrical. Things like shoreline relates to electrical. The buildings relate to thermal and electrical. So they're all interacting. So we always look at this, and one of the key factors that we found in making an efficient infrastructure is to make sure you start with solid planning. And the solid planning is something that can relate to a green field, but also to a brown field. So this is where we help customers a lot. For example, in Rotterdam, you can see here the M4H harbour transition. We help them there. We're also now working on their activities moving towards carbon zero, CO2 neutral. So a lot of work being done there. Also with Bremerhaven, we're doing work with them, supporting them to achieve their CO2 neutrality that they're working on. But also considering things like the sector coupling and all of these different aspects that need to be done. So interesting, and this is where you really need the domain knowledge and also the solid electrical knowledge or infrastructure knowledge to be able to best support the customer making the right decision. Okay, so a very interesting aspect here. The other aspect that we work a lot with is electrical efficiency, or efficiency with energy. And this is something that typically we take a stepped approach for. We will firstly do a type of baselining to understand in a terminal, for example, where the power is being consumed. Because very often the terminal operator doesn't really know what and where the power is being used. So this is a baselining that we do. The second thing is, based on that, after analysis with the customer is defining the corrective measures that can be put in place, implementing these measures, and then having a continuous improvement process. This is important because we found that terminals or ports are changing the whole time. You're getting a new ship-to-shore crane coming in, you're getting all sorts of upgrades happening, and that's why you need a dynamic process that can cover all of that. So, do a lot of work in this area too. This next example actually shows how this works with a real-life example that we implemented. And if we start, for example, top left, number 1, you see the transformers. And you think, well, transformers? Well, a transformer is much like a diesel engine. It has its efficiency band where it works most efficiently. And very often, you'll find that the transformers in a terminal or in a port are not properly balanced. They're not working in their sweet spot. So what can we do to that? How can we balance the loads better? The next thing is renewable integration. How can we work with renewable? How can we work with storage? Quite a broad subject, and they're working with the electrical power utility on the one side and the customer on the other side. We can really bring the parties together and make sure we get the right solution. Working with the reefers, how to manage them, retrofitting RTGs, retrofitting motors, all of this sort of stuff has to happen to get electrical efficiency up. And then a big thing, of course, is peak load management, because very many terminals have found that if you don't manage your peak loads, you're going to be paying extreme penalties to the power utility. So there's some very easy examples how to do it. And one nice example is that we did here is with the Vale iron ore terminal in Brazil, the Cuiabá. There we're working with the customer and the service provider and have implemented a significant cost saving for the customer there, be it money-wise, be it CO2-wise. So makes a big impression on everybody. Okay, so that's the one aspect of intelligence that you can have in a smart infrastructure. The next point I want to talk about is something called a self-healing grid. Now, an electrical grid, unfortunately, sometimes can be disrupted. You know, we all know you have some construction work going on, front-end loader is digging up something, and what does he do? He hits a cable, yeah, and he causes an electrical fault. Now, normally what would happen is the power would shut down because you detect the fault, and then everything would be off for a while. However, with this system, we've automated it. We detect the fault. We then have an automatic system which then speaks to the different players, the different substations or the distribution stations, and then automatically detects the fault and isolates it so that it's safe, and then restores the supply back. Now, this all is automatically and in less than 300 milliseconds. So that's less than half a second. And this is critical because you want your process in a port or in a terminal to keep running. And you don't want it to stop because some guys dug up a cable somewhere. And this is something that happens. And this is proven in Rotterdam. So this is reality. It works very well. And so I can only encourage you to use technology like this to get some intelligence into your infrastructure and make it smart, and then get the savings from it. Okay, so really interesting stuff happening there. Of course, the other thing, which I think everybody knows about, but can't go without saying, because if you're talking about greenhouse gases, and we've heard from earlier presenters about this, we have to consider shore supply. Now, the shore supply is really maturing, it's really picking up, especially in Europe. And it's not only applying to cruise vessels, it applies to all sorts of different vessels like utility vessels, cargo, row, all of these different types of vessels are now in short supply. So this is something that is working and is really a proven thing today. Okay, the final thing that I want to talk about is the fire security, safety, access control side of things. Now, typically in a terminal or in a port, all of these things are standalone systems, which in themselves they work okay, but it is impossible, almost impossible to get synergies between them. How do you get efficiency up? How do you do automatic dispatching? Because this is where you really get efficiency. And so this is the sort of thing you want to drive towards, to have all of this running in one system, which we've done now in the port of Manatee in Florida, for example, where this stuff works automatically together. So dispatching happens automatically. If there's an incident, the closest and correct person gets automatically dispatched to look at the problem and resolve problem. Why is this important? The quicker you resolve an issue, the quicker you get back to normal operations. And it's important that this whole thing is automated. Also the documentation, because in many countries today, a breach of security has to be documented. It has to be proven that you responded in the right time, the right way. And this system does this type of automatic verification of what you do. So, also a very nice example. Just keeping an eye on the time. I just want to wrap it up quickly, just show some nice examples, going from left to right, all the decarbonization work that we do. I mentioned Rotterdam, Bremerhaven, for example, integration of renewables, doing nice work there, for example, in Antwerp with wind turbines. Things like good, solid electrical power supply for ports and terminals. I mean, this is something we did in Qatar. Really nice project, state of art, really good, solid, resilient power supply. Resilient meaning stable, reliable, good quality under virtually every condition. Shore supply I've mentioned already. So, various different examples. And of course, what I mentioned, the Port of Manatee. Many other examples too. I mentioned the Vali example, where we use storage to significantly improve the customer cost position and the greenhouse gas story. Okay, so that's it really from my side. A very big subject, but